Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Francois Bertrand.
Hello.
We also have Ben Wilson.
Hello.
I'm Charles Max Wood from devchat.tv. Just rolls right off the tongue. I've been doing it for 10 years. Topendevs.com is where you want to go for that. Anyway, Ben brought up, he was like, I don't know if this is going to be interesting to you guys, but I always love talking about testing. It's like, okay, how do you know if this thing freaking works, right?
Mm-hmm.
And then it's funny too, because I was talking to somebody the other day and we were discussing testing and they were like, well, I bet they test everything in the banking and medical fields. And I just fell out of my chair laughing. I mean, I was laughing so freaking hard because I'm sitting there going, hey, I've worked on financial apps and I've worked on medical apps, and getting those guys to test was like pulling teeth. Now, I think some of the embedded systems people that work on like pacemakers and crap, yeah, those guys, they probably tested most of their stuff. I don't know because I haven't worked on those projects, but I'm telling you that the billing and banking stuff that I've worked on, the stuff I wrote got tested, automated tests, and I had a skunkworks CI/CD. But yeah, so I'm curious. Yeah, if I put together an ML, because it still feels like in a lot of ways there's some black box-ishness to ML. So how do you test it? Like, how do you know it's giving you correct answers?
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Yeah, I mean, it really comes down to the reason why people don't do tests in ML is because of the process that most data scientists go through. And I've been guilty of this in the past many, many times early in my career, where we start with an example that we get from a website or from a book or from the getting started guide for a particular algorithm. And we'll take our data, we'll do some very simple cleanup to it, we'll run it through to make sure it works, and we'll tweak it until it actually does work, until, in a notebook, we're getting a result, a pandas data frame that's like, okay, we get predictions, sweet. They may be terrible, but we get something. And then as we go through the process of making that better, we're building visualizations in there. We're doing statistical tests on our data. We're making the model more robust. What that is just monkey patched code into that massive monolithic script over and over again. And just, it grows. Sometimes you have bunches of code that are put into notebook cells and you're executing it out of order. You're like, all right, I'm going to run cell block 17, 13, and then your kernel crashes. You run it again from the beginning. Nothing works because it's like, this is not defined. But
by the way, it's cell block 1138.
That is a very good reference. When you go through and write code in that way and then get ready for production, sometimes you're handing that off to an air quote ML engineer or a software dev, and they look at this mess and they're like, what the heck is this? I don't even know what to test here. I don't know how to decouple all this stuff. And it could take months for them to refactor all of that into something that is going to work. But sometimes it's the data scientist that has to push that to production. And what do they do sometimes? They just rearrange the cells. They get it so that something just executes and they get the results that they want. And then they release it to production. It's a scheduled job that does retraining or does predictions every day. But the problem is no software deployment for ML projects is ever complete. It's always like an organic thing. You're always improving it. You're always changing it. And if you're not decoupling all of that, the things that you're doing to the data, the things that you're doing to the model in such a way that you can make sure that your code works, when you make that change, you're now debugging a massive script. And some of these things, some scripts that I've written, years and years ago, there's thousands of lines of code, and they can take, hours to run. And if something blows up in the last 10 seconds, like you can't serialize your model properly because you screwed something up, or you wrote it in the wrong format, or something happened in the post-processing logic. Well, in order to debug that, you now have to rerun it from scratch again after your small little change. And you have to keep on doing that. And it just wastes days or sometimes weeks of time. So it's interesting to me that in a lot of the communities that I'm a part of and a lot of the people that I talk to about MLOps, people are now starting to kind of have this revelation of, whoa, we can test our code. And then you see some of the software devs that are kind of in these channels or in these discussions, and they're sort of snickering to themselves. Like, yeah, well, we could have told you this years ago. Like, that's how we do stuff.
So in that case of the very last step failing, are you talking about testing each chain link individually with unit tests? Or, I mean, in video games, we had a thing where you can, jump to any level if you wanted to test a certain level. So you have something where you can have a kind of a fake setup of data for that last step that emulates what, out of 10 steps, step 9 would output this kind of data. And then you use that kind of mock data and then run a bunch of unit tests on that last link, or how. Yeah, what are kind of the approaches you test something like that?
Are you asking what people do or what they should do?
What they should.
What they should do is exactly what you said, creating mocks. And in the parlance of data science, that is almost exactly what you said. It's like you're creating this mock data set that represents what the input should be based on what you understand of your process that you've built. You're like, hey, I know I'm supposed to have these 17 columns, and I know that the 17th column needs to be an array of float 64. And so I'm going to just mock up. You don't need to create a data set of that. Just create one row of that. So you pass that data into that function that you've created that wraps that last phase of processing, and then have an assertion and say, hey, make sure that it exactly equals for stuff that is deterministic. Use like NumPy array, assert array equals between these things. But there's a lot of other tools, and I see data scientists get frustrated when they try to sort of copy stuff off of Stack Overflow. They're like, hey, I see all these assertions, and that's how you're supposed to write unit tests. But there's also fuzzy matching that exists in a lot of these libraries, not just because of floating point precision, which is a headache to unit test around in the data science world, but also for non-deterministic tests where you're building a model. It has some, even if you set a seed value for the randomized search that it's doing, it's not guaranteed to be consistent every time you run it. But when you look at the actual data, it's usually pretty close. So you can do most libraries that support assertions like NumPy in Python has fuzzy matching. So you can say, are these pretty much equal? Even though at the 11th decimal point, it's never going to match up. So you use that assertion, say, hey, it's close enough. It's actually, you want to test that the functionality works, that your code is working.
Right.
And it's important not to conflate that with integration tests in ML, which is, those are more, am I solving the business problem? Did my model score itself accurately? And that's what we use metrics for. So like, hey, calculate my loss error metric. But those are not unit tests. And that's the thing that is hard for some data scientists to kind of conceptualize, because all they're concerned with are their metrics. Like, hey, what is my area under ROC? What does my confusion matrix look like? What is my root mean squared error? That's all I care about for the model. And yeah, you need to care about that, but you should really care about, for production MLOps approved code, you need to be testing each of those little components every time you're manipulating something. Mock it up, test it, make sure that it basically functions the way that you want. Because not having that stuff, not having any of that stuff in place, when you go in a week after you release that to production, you realize, oh, geez, we really can't include that feature in this because it's not consistently available when we need to make predictions. I need to remove this feature from this entire model. If you don't have those tests set up, you're not getting that done in a day.
Well, the thing is that most of the time, I have to say, most of the time when we see errors in any system, it's something like ridiculously mundane, right? So it's not the, oh, well, the square root of the blah, 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 and this algorithm that I plugged in on this massive edge case. No, you divided by 0 and you didn't have a test on it. And so it goes math error. You can't do that, right? Or you're calling a method or a function that doesn't exist. You can't do that, right? And so you put the unit test on, and it goes, it tells you that before you deploy it, right?
Yes.
And then the rest of it is, this should give me a predictable result. And so I'm going to test that it gives me the predictable result. And when you think about testing in that way, unit tests become really simple, right?
Yes.
I mean, sometimes you have a bit of complicated logic that will give you a predictable result that you want unit tests on. But most of the time, you're testing a handful of outputs for a handful of inputs, or a handful of side effects for a handful of inputs. And you're really just testing to make sure that it works, right? And so you're not doing the, like you said, kind of the non-deterministic model output. What's going on here? We don't know exactly what this engine's going to give us. You're testing
does the engine work?
This in, I get this out. When I do this, it does this, right? And some of your tests, even your integration tests, might be, I put something in here and I get a response back from the machine learning model, right?
Mm-hmm.
And you don't even care what it is. You just know it's supposed to be a number, right? Yes. And so you can even go that far, and you're not testing whether or not the model's good. You're just testing that the system works.
Correct.
And that it follows the pattern that you expect it to. And what's really interesting about that is then if you can get that to run quickly, you can run it in development and then the long running stuff you can run on a CI/CD system, so if it takes more than a minute or two is generally kind of where my red line is. If I run my tests and then I get lost on Twitter before my tests return, right? I get bored, I go to Twitter. I get bored, I pick up my phone, right? Then the tests take too long. Something has to go to CI/CD. Mm-hmm. And so the rest of it's just a check that says, hey, it all works. Go ahead and commit it, right? And that's all you need. And you can automate all of that. And that's the other part of it. And so, you got me on my soapbox because most of this testing stuff is simple.
Yep.
And it'll save you all kinds of embarrassing, stupid stuff.
Yeah. And debugging becomes much simpler too. I have a general rule of thumb now when I'm writing code. For every 15 lines of code or 2 functions that are written, I run all of my small unit tests. I just have a terminal window open on another screen while I'm doing active development. And even if the IDE is saying like, yep, everything's good, I can resolve all this stuff, I'm still kicking off my short unit tests. So, and it's funny also that you said anything longer than a minute, you have way more patience than I do. I have a 10-second rule. So unit test takes longer than 10 seconds. That is a PyTest fixture mark of large of like, hey, you run this on CI/CD, but everything else in local, there's things that are almost instantaneous. They take 5 milliseconds or something to run. Build it up, tear it down, mock up, the state of your class at that time or whatever the input needs to be. It should run very quickly. And when you're debugging or when you're in development, it'll catch stuff that if you were to try to debug that later on, if you had no tests, you'd have to hunt and search and try to find out, like, why is this broken? Okay, now I need to do binary search through my code base and say, putting in print statements and stuff, which that's one of the things that I see in a lot of data science code bases are ubiquitous use of print statements everywhere. And that's their debugging. Say, hey, when I execute my script from top to bottom, print the state. It's like saying, starting training now, here's a representative row of this. And then finish training, here's all of my metrics and all of my parameters. It's like, you don't need to do all that. You just write a test that asserts that. And if something's broken, it'll be like, yep, this doesn't work.
Anything on the, and it feels like this goes without saying, but I'm curious to see if you've seen it out there. Anything on the, I'd say the deployment side of testing, having a develop versus production kind of set up, and then you just flip a switch and all of a sudden it swaps to the new model. Something where, it succeeds with your local unit test, but when you give it fire hose of live data, something could be tested for or at that stage before flipping the switch.
So those sorts of integration tests are usually, it depends on what the severity of the implementation is. And what I mean by that is, think of it as a poker game. How serious are you is directly correlated to how many chips you have in the pot. And the more chips that you have in the pot, the more you're going to be careful about what your next move is going to be. So the stuff that Charles was just talking about, financial services, and I've worked with a number of customers in that industry that some of their ML projects they're big deal stuff. Like they're trying to do automated fraud detection, like shutting people's cards off in real time. They take that stuff very seriously because they don't want to get it wrong. They really don't want to not get it right more than they don't want to get it wrong. They don't want card authorizations for $100,000 of fraudulent activity that they have to pay for.
Yeah, but it does tick me off when they shut my card off when I'm traveling too.
Oh
yeah, that's what I was going to say. It's kind of a lose-lose situation.
Yeah,
I'm like, you've prevented fraud, but man, am I annoyed. That's
my account being empty would also tick me off.
There you go.
Yeah. So what you typically do with that, if you have an online model that's serving real-time requests, you'll do a shadow deployment. So you'll get all of your unit tests to pass to get your candidate release of a model, and then you put that into sort of this shadow realm. It's processing traffic, it's making predictions, but those predictions aren't being consumed by any downstream process. So no business logic is actually saying, hey, model B just predicted that this is fraud. We need to do something on it. It's now, all it's doing is saying model A is current production deployment. The new one that we want to replace it with is B. Let's see how much agreement there is between A and B. And hopefully after a period of time, B starts to outperform A. So you can flip the switch and say, all right, we're retiring A, all traffic goes to B. And that's the most serious integration test, CI/CD for ML models that I've seen, is doing that for a number of days, collecting hundreds of thousands of rows of data and really doing statistical validation on it. But there's other stuff where you don't have that much skin in the game. You might have just put the ante into the pot. You don't really care that much. In that case, sometimes you can get away with blue-green deployment, where you're just making sure that it actually passes traffic properly, and you run some records through that are actually going out to interface with the rest of reality, and you just make sure that the aggregate numbers there aren't terrible. And then you just say, all right, switch it over. And then there's more sophisticated versions of that, like bandit algorithms, where it'll divert traffic dynamically to the new model while still keeping the old model in place and saying, do I have statistical significance that I'm at least not worse than the current production one? And if so, if it continues behaving that way, divert more and more traffic to it, to whichever one is the winner at the time, and then eventually retire the old one.
Bandit algorithm. That's kind of cool.
Yeah, multi-armed bandits.
Oh,
a lot of people,
that kind. Yeah.
Yeah, a lot of people talk about them in the MLOps community. I can honestly say, after talking to hundreds and hundreds of companies in my career and all the stuff that I've built, I've seen 2 of those in the wild from all time. But I've heard it from hundreds of people. They're like, "Oh yeah, we're talking about doing that." I'm like, yeah, good luck. They're really complicated. But people, there are people that are doing them, and it's more of what is the velocity of your drift that's happening to your data set? And fraud is an excellent use case for something like that. If you're a company that is constantly under attack by criminals who are just trying to defeat your algorithms and trying to not get detected, if there's human minds involved in doing that, you have to retrain pretty frequently. Sometimes, some implementations are retraining twice a day, and they're constantly trying to say, hey, is this performing better than what is currently out there? do a shadow deployment, but once that shadow deployment is over and we verify it, then deploy it. And this time span could be measured in less than a day where this is happening. That new model goes active, it'll start diverting traffic to it pretty aggressively in order to defeat people trying to counteract how that model behaves.
Yep.
Yeah, no, that's a really interesting situation, like cat and mouse game and tug of war between the fraudsters and the algorithm.
I'm kind of curious. So you kind of went into some of the A/B testing and improving your model. Is that how you test the non-deterministic stuff?
Well, non-deterministic would be like, hey, I'm running an algorithm that I have an expectation on a prediction on a fixed data set. I have like, hey, all things being equal on a deterministic algorithm, my predictions for a sample data set should exactly match because the way that model trains is predictable.
Yeah.
It has some fixed seed and it just goes through iterations and it'll do it the same way. So as long as you're on the same hardware. But there are plenty of algorithms out there that, it doesn't matter. Like it will train in different ways. And I see this, actually, I saw this a couple of days ago when somebody was asking me about an explainability tool for ML SHAP, which is pretty popular in the Python community. And they're like, well, I'm getting different results every time I run it. And I even set a seed. I'm like, well, check the algorithm, like see how that does what it does. And it's a random search within a random search to create candidate values. So even if you seed the random seed, that's only on the first layer. The second layer is still always going to be random permutations of creating candidates.
Yeah, that's what I was going to ask. Is that just the algorithm not using the seed consistently, or somebody kind of giving up and saying, okay, I'll just use random from the machine at this point, on purpose or not? But you'd think that when you think that it should be, if you give it a seed, it should be deterministic.
The way the algorithm is built is intentionally non-deterministic, though. So it's supposed to give you random samples in order to measure the effectiveness of your model's interpretability. And there is a way to brute force it to be like 100% deterministic, but it's a little bit more complicated than just saying like numpy set seed. You have to do stuff on the instance seed of that inner process. So it gets a little hairy. So when you're trying to test stuff like that, you need to create sort of boundaries of saying, here's a threshold that I'm sort of expecting that my prediction to be within. And so long as it's within that, I'm going to call it good. But that's all exactly as you said earlier, Charles. That's all after those unit tests are done. Like those should be deterministic and they should be really fast and prove that the plumbing works.
You've mentioned having real quick. You mentioned go ahead, Dan.
No, go ahead. I was just going to say the unit tests are low hanging fruit. They're easy. They're fast. You should do them first.
You mentioned having a single row of data, for example, to just run it through the algorithm. Have you found that, some situations where having a bunch of rows, maybe with certain combinations of missing fields or denormalized floats or whatever, is there any value there, or generally you haven't really, it's really just a matter of going through the motions with, any type of data?
It really depends on what you're doing. I mean, if you're testing something similar, like something simple like ordinary least squared, you're just fitting a regression to something. To train that properly, even in a unit test, to say, hey, does my model train? The question that I always bring up to people is, why are you testing open source code? Right?
Giving back to the community.
Or like sklearn, for instance. And I've seen data science teams do this, where they have a unit test that it's wrapped around a function that the only thing in that function calls sklearn or it calls TensorFlow of like, hey, create this class and run a fit based on my data. And then they're testing the results coming out of that. I'm like, why are you testing whether the global ML algorithm community who has contributed to sklearn over the last 13 years, why are you testing whether they know what they're doing? Like, they know what they're doing. You don't need to test their code. They have a lot of unit tests. So let's test your custom code of all the stuff that you're doing to the data that's coming into that model. And because the community is not testing your code, but they're testing that little part that you're wrapping.
And if there was a problem, someone will find it.
Oh, yeah. And if you do find a problem, don't write a test in your code for it. Write an issue on the GitHub repo and say, hey, here's my repro. Like, here's some sample data that I did. I'm getting a result that I don't understand. Can somebody who understands this code base really well explain to me what's going on? And they might be like, hey, thanks for finding the bug. Do you want to contribute a fix?
Yeah.
But yeah, for doing that test of complex data structures that are coming in, when you're doing like an integration test for an algorithm that could be potentially non-deterministic in some way. When I do an integration test, I'm taking a snapshot of historic data, and it's not the entire data set unless the algorithm requires it. And there are some algorithms that you need to test on a lot of data or the model just won't fit properly. So if you're doing like time series forecasting, you're using Facebook Profit. You can't feed in 10 rows of data and expect that it's going to produce anything useful. It can't even solve on that little amount of data properly. So you need to throw in 400 data points in order to just get it to produce something that's useful. But there's a difference between passing in 400 data points to do the unit test and 400 to do the integration test. There's a huge difference there between that and passing in 450,000 data points to do your tests, because it's going to take forever to run and it provides no real value to you. If you need to do that pre-deployment check against all my data, that's when you do shadow deployment. Run prod against it, but don't consume it anywhere. Create a Docker container that's just running this instance of this model and is writing it to a QA database that you can then run tests.
Hey folks, it's Charles Max Wood, and I just wanted to jump in here and let you know about something that I'm doing. It's free. It's out there just to help you get answers to your questions about the things that you're running into with your career. So if you have questions about how to get further ahead in your career, how to start a podcast, how to get a better job, how to get a raise, how to deal with a situation at work with your boss, or just maybe you're stuck and you don't know where to go next. You know, how do I get from junior to senior, senior to whatever's next? How do I become a speaker? How do I get to the next level? That's what I'm out here to do. So every Wednesday at 12 o'clock Mountain Time, I'm going to be doing a call, and it's going to be free, totally free. Go to devchat.tv/levelup and you can register for the call. It's using Zoom's webinar software, so it's pretty straightforward. And what we're going to be doing is I'll do 10 minutes and I'll just show you how I do some form of how I level up. And then we'll just answer questions. And it's not going to be a question and answer like, hey, what's your favorite flavor of ice cream? And then I say Rocky Road or whatever, right? Instead, what we're looking for is more along the lines of, I have this situation. How do I handle it? I'm trying to figure this thing out. How do I figure it out? I'm trying to stay current. How do I stay current? And if you have any of those kinds of questions, I'll bring you on the call. We'll ask some deeper questions. We'll make sure we get you a solid answer. And I'm really looking forward to helping some people out. There will be no sales, no selling, no nothing on these calls. It is literally just 10 minutes of training and then Q&A. So you can go check it out at devchat.tv/levelup.
One other thing I just want to put out there, because sometimes, by the way, I have seen the instance where, essentially you have a method like in Ruby, and then, it calls one method out of like a Rails library, right? It's the same deal, right? And then, somebody has a test around it that, hey, I got an instantiated ORM object back. And it's like, you'll get that every time you call that. But sometimes what happens is you have logic before or after that you also want to test. And so that's where mocking and stubbing come in, where you're going to, mock out or stub out that call. And so essentially what you're doing there is you're saying, hey, don't go run all the code behind it. And especially if it's an expensive call, you especially don't want to be making that call. But then you give back something with the characteristics you need to test the rest of the code. And the rest of that code should be deterministic, right? You should be able to predict how it's going to react to what it got back. And so that's kind of, I think of as kind of a level 2 unit testing. And most mocking libraries are pretty straightforward. You're doing mock stubs or spies. And from there, you should be able to handle most of the stuff in your unit tests. But overall, then I like what you're talking about with the rest of it, where it's like, anything that's expensive in the sense that, I have to load zillion records in. It's going to take forever, and you're not going to run your tests. And so there's no utility to that because you're not going to get the fast feedback. And that's actually what you want.
Mm-hmm. Yeah, I once saw a customer's code base that after our first discussion, they were saying all the right things. They're like, we've got unit tests on our code. We just wanted you to come in and just do a code review. That's all we need. I'm like, all right, that sounds good. And they had these code coverage reports that I was like, wow, they're at 96% code coverage across this code base. That's pretty impressive, actually, that anybody would waste that amount of time doing that. Maybe it's because of the design of the code that it's like that.
Mm-hmm.
And I'm looking at the repo and I'm seeing everything looks pretty darn good. I'm like, I don't really have that much feedback. Like maybe there's some linting stuff they could do here. And like, hey, don't forget to, don't capitalize that and make sure it's an underscore here. And it's just like nitpicky, stupid things in Python that I was finding, but everything looked pretty good. And then I was like, all right, let me see the results of the CI/CD or just the CI. And they're like, oh yeah, here's the result of it. And I'm looking at it, I'm like, how does this take, 19 hours and 37 minutes to run all this? Like, what the hell is going on? And I was like, okay, let me look at the test folder. So I go into the test module and every single test calls the main class to basically build the model from a test data set that was present. It was just sitting on S3.
Mm-hmm.
So they're not mocking and stubbing anything. They're just running the entire pipeline 831 times. I'm like, what are you doing? Like,
mm-hmm.
Is this what you want? And they're like, well, we didn't know. And I'm like, okay, let's make this way simpler. And that's how we spent 2 weeks working together, was just getting their unit tests to finish in less than 11 minutes.
Mm-hmm. Yeah, and this is the core of what I call confident code, and that's a term I've stolen from a bunch of other people. But then you can run the tests every dang day, every time you commit, and it's like, oh, I know at least all this stuff works, right? So when I commit, I can be confident that it works. And then if something breaks, then I go write a test around that, and I can be confident about it too.
Yep.
Yeah, one thing, I'm not sure how pertinent this is going to be for this discussion, but I don't know if, Ben, you ran into anything with stress testing, talking about deployments and things like that.
That's not with data scientists. They don't usually deal with production deployments in like REST APIs. There are some teams that do that. It's usually at startups or really small ML teams, but you're going to have somebody who's a traditional software backend software developer that's working with the data science team to show them how to do all that. So that's specialized knowledge that most data scientists don't have. But when you're talking about stress testing, if you're a B2C company, like your company interfaces directly with your consumers through an app, through a web portal, or making decisions on individual humans that are your customers, performance really does matter. And you have an SLA budget associated with your algorithm, whether you choose to accept that or not. There's only so much time. If you're populating something on an app or on a website, the front end dev team is not going to wait for you to have your predictions ready. They're going to have fallovers. They're going to have defaults that they will show that if your stuff is not ready in time. So it's important for not only doing the stress testing, but understanding what those thresholds are way before even the first line of data science code is written. So you can say, hey, front-end devs, can you work with us for 2 weeks? We're going to send our design docs over to you so you can vet them and say, is this even going to work with your architecture? And can we work together to make sure that this is successful? And you'll get all that knowledge from the front end, JavaScript developers or Python developers that are going to come in and say, hey, you guys aren't building this REST API right. We need to elastically scale this, or hey, the way that you implemented these features is incorrect for what we need this behavior to be like. We need to time out after this amount of time so that we get a response that says, hey, we're just not ready, or there's some other issue. So that stress testing, it's SLA, but it's also volume. And yeah, you better make sure that if you're selling stuff, that you're testing at 1.5x or 2x, whatever holiday volume is going to be. And that's the criteria, that you're still hitting your SLA for whatever your infrastructure is. And there's tools to do all that stuff. But
you'll probably wind up working either with SREs, which are site reliability engineers. A lot of times their work boils down to performance, or your operations folks. And then in some of the rest of it, it'll come down to code and optimizing the code so that it's efficient. But in a lot of cases, you can get away with a lot just by putting more hardware behind it, or by figuring out where the bottlenecks are with memory or CPU and accounting for that, or load balancing across multiple machines or things like that. And then you can start looking at, okay, where's the next piece that we hit? But there are people that specifically solve these problems, and in bigger organizations, they have them, and they'll just come in and help you out.
I guess as long as you have a good architecture to begin with, that's in the ballpark of what you'll need, I guess. And when you get to that final stage, you can optimize it.
Yes, and also keeping that model.
Even then, a lot of these guys, they'll come in and they'll say, hey, these are the big gaps that you need to fill so we can solve these issues.
And also, it's really important for data scientists to involve those teams very early on. If you know you're having something that is going to be facing to the outside world, and it's not something you just write into a database, talk to those experts, get them really involved in that project, even though it might seem overwhelming and it might seem premature to talk about this. But knowing what that SLA budget is informs your testing that you're doing, your prototyping work, where you're saying, all right, I have 5 potential algorithms that I could use to solve this problem. I'm going to test all of them, but not just for the data science accuracy aspect. If it's something that's going to be, served as a REST API, part of that evaluation and testing needs to be those SRE people coming in and saying, hey, does your model actually return data, even in the best case scenario? Does it meet our SLA budget? And spoiler alert to a lot of people out there, there's a lot of algorithms that will not, for particularly modern day web apps or mobile apps, or even worse. Sometimes you have an SLA budget of 50 milliseconds. And you have an algorithm that it will not return in less than 400 milliseconds. Well, that disqualifies that. Even if it is so much more accurate than anything else, if it doesn't fit within the needs of the business or the architecture of the front end, then you can't use it.
Isn't that what happened to the original Netflix prize algorithm, like way back when? Remember that one?
ALS?
I don't remember. I just remember reading that they had the first $1 million contest for doing a Netflix recommendation algorithm, and they picked a winner, but it turned out to be so heavy that they couldn't use it. So,
yes, that is ALS on Spark.
I have no recollection of the details, so maybe I'm getting some of this wrong. But I thought I heard that, and I thought, okay, that they were doing this huge aggregate thing that was just way too big. But you might know more about it.
Yeah, ALS, alternating least squared. It's collaborative filtering on Apache Spark, and it's not something that you can train on the fly. It's not something that you can create like an artifact of and then just use it to do predictions, because of the computational complexity involved in doing the lookup, because the data structure is just massive. You're storing a ton of data in that model artifact, which are the relationships between users and items, or users to users, or items to items. So those matrices that are being stored are very, very big for something like Netflix, where you have millions of customers, millions of titles. It's big. So one of the ways that you can get away from SLA requirements for something like that is to pre-calculate your predictions, which is what a lot of people do these days for recommendation engines on websites and on apps. You just run it overnight. You get your predictions, you write them out to a NoSQL database, wrap a REST API and Elastic serving around that, create a caching layer, and you're off to the races. You can hit, if you're querying Redis for cached data, when somebody logs into an app or logs into a website and you're doing an asynchronous prefetch into Redis, what is that? 1 millisecond? You're going to have however big that payload of data is going to be there for use by the JavaScript engineers.
And I feel bad for having brought this up, because I keep thinking in the back of my mind that for most people, this could be a case of premature optimization is the root of all evil. So your project may not, don't get tripped over, oh my God, milliseconds, this and that, or because it might not be relevant anyway. But that was interesting.
Yeah, but if you're paying attention to it, you know that you have to solve it earlier.
Yep, and it can actually save you a lot of money and a lot of time if you have that conversation with the ops people, have it with the DevOps team, with the actual front end developers, with back end engineering. Just have that conversation to say, hey, the business wants us to build this. We need this to integrate in order to solve the problem in the app in this way. How is this going to work? And a couple hour conversation with them could actually tell the business, we can't actually build this right now, or we will need to re-architect how the app works in order to support this. And that gets the appropriate amount of scope put onto the project, not just the data science ML part, but the entire engineering, project that needs to be built can be well defined, and then you can give the go, no go before anybody starts writing code.
Yeah. So the other group that you want to get involved pretty early and may need to do some testing around is security. So you get your SecOps folks in.
Yeah, you definitely need whatever your company's requirements are on what can and can't be accessed from that API, as well as making sure that there's another aspect of ML security that not a lot of people talk about right now, but I think maybe they will start talking about it in the near future, is what data are you using for your model? Like, what is the nature of that? What goes into that prediction? And is that something that your company would be okay with being out on a front page of a newspaper somewhere someday? Like, hey, we're making decisions on your loan approvals based on, self-identifying characteristics that are potentially racially biased. Should that be handled and discussed with an ethics committee at your company to say, hey, is this secure and is this something that we should be doing?
Yep.
That's like a whole other podcast episode, though.
Yeah, it is. It is.
Ethics and AI.
Well, it's something that seems to be brought up more and more often, right? So how is it being used? What are the predictive qualities of this? And how does it affect people in real life? I mean,
One thing that freaks me out personally is deep fakes coming into a world where we won't be able to tell if a soundbite or a picture is real. And it's incredible. Just thispersondoesnotexist.com is scarily good.
Yeah, it is.
The backgrounds they're not getting right, but the faces if you're not carefully looking, it's pretty amazing.
Yeah, I've got one or two that are just funky weird. Like, I don't know how it put it together, but it's wrong. But most of them, it's like, that's really not a real person.
Yeah, one of the only ways that we're going to be able to detect things like that in the future, as these algorithms get more sophisticated and trained better on more data, the only way you're going to be able to detect them is to have an AI that can detect that this was generated by an AI. Because there's certain patterns in the pixels.
Yeah, right.
Yeah, I think that
the convolution that's generated from an autoencoder when it expands a compressed signal into the final full resolution image, there's attributes associated with those matrix operations that you can the human eye would never be able to tell. And even just looking at the data yourself, you wouldn't be able to pick up that pattern, but another AI can.
I think there was a Kaggle competition about that, like a year or two ago, actually, try to see which things are the deep fakes. But
Yeah. Anyway, we're kind of up against our time limit, so I'm going to push us to picks. In fact, we're past when I was supposed to leave, but I don't care anymore. So let's go ahead and do picks, though, because I do need to get off to this other stuff. Are there good resources, though, before we run off to that, Ben? Besides sort of the ones that I'm aware of are more on the programming, testing end of things.
I mean, I'd say they apply directly to what data scientists should be doing with their code, even in early development phases, because it saves you so much time. But a great resource for most people that are doing data science work who are writing in Python, read through the PyTest docs. PyTest is probably the best test suite that's out there for Python, in my opinion. It's at least the most widely used. Get familiar with those APIs, understand how to write proper fixtures, how to write proper tests. And yeah, it helps inform how you should be writing your code as well. Because if something's not testable, or it just takes too long, or you can't actually test that functionality, you need to refactor.
Yep.
Yeah, no, that 19-hour test thing you mentioned was a brilliant example of that. And testing library functions directly also. Like, yeah.
Well, I have an example of that I'll just throw out real quick. This was like 10 years ago, 11 years ago, but I was working this job, and, I'd pack up my stuff and go home, and I'd come back for like a week. I'd come back and check out the code and get to work, and I'd run the tests, and I'd get this nasty message in there that said, "Hey, Chuck, you blew up the tests." They were passing when I checked in and left, right? And the CI was catching them at night, and it was a time zone issue, right? But it's that kind of thing. I had to like rack my brain and go, okay, what the heck was I working on the other day? That's why you want that fast feedback. That's what we're talking about. That's why you make it part of your process, is so that at the end of the day, you have this reliability aspect to your code that you can go back to and say, I know this works, or at least, and tests can be faulty too, right? They can give you false positives or false negatives, but at least you have something checking the code that you can rely on. And then when it isn't, when the tests aren't working for you, you can fix them.
Yeah, who watches the watchers? Yeah.
Yeah. I know. I want an AI algorithm that tells me when the AI algorithm that checks for deep fakes is lying to me.
Yeah.
Right? So,
turtles all the way down.
That's right. An AI algorithm that checks on the other AI algorithm that checks for AI algorithms. Anyway, but yeah, let's go ahead and do picks.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Francois, do you want to give us some picks?
Yeah, no, I'll do a pretty soft one, but it's such an event that it has to be mentioned that Dune is coming out, so it might be a good time to revisit the original books, which I might have mentioned this a while back, maybe with the Audible one, but I've been going back through them. Realized that I didn't remember a lot of stuff, so from 20 years ago, so it was kind of like rediscovering it. So it was great stuff. There's also a bunch of new ones that came out, surprisingly good. You'd think like sequels written 50 years later would kind of lose a sense of the original, but the writers, I think it might be, I don't know who they were, but I thought they were related to Frank Herbert, but did a good job of capturing the spirit. So there's like 20 or so books now, and it's a really great, unique universe to get back into now that it's all over the media now. It should be an interesting movie. They say the movies are better for people who've read the book for what that's worth. So it's a good time to revisit.
Yep. Yeah. One of the guys on Adventures in Angular keeps telling me to read the book. I'll have to check it out. Ben, do you have some picks for us?
Mine's an anecdotal story about something we mentioned with ethics and AI. There's a data set out there that all of us are familiar with who do ML. We're trying to test stuff out. It's called the Boston Housing Dataset. It just made news recently, and it's actually being pulled from the examples of a lot of open source packages due to the ridiculous content that's in the actual data set itself. And if nobody's familiar with it, there's a particular column in this data set that just has a single letter, and it's just the letter B. And people have done, analysis. I've done it in the past. I had no idea what the data actually was. And you always find that column really predicts well. If you remove it from the data set, your model doesn't do that well. But if you put it back in or overemphasize its importance, your model performs really well. And it's predicting housing prices of what the tax valuation is in Boston. Back in, I think it was like in the 1960s or something, Harvard did the study and created that data set. Well, it turns out that B is a Boolean value for, is that family African American or not? And it directly correlates with that taxable housing price based on the area that it's in. Super racist data set. It's kind of interesting that it's being removed from like sklearn's pulling it, everybody that has it embedded in their packages. So if anybody has code that relies on that, kill it with fire. It needs to go away, and it is being pulled from a lot of repositories.
That's interesting. Yeah, the ethical implications. I mean, I'm sure there are other data sets too that have, similar issues one way or the other. But the other thing that's interesting is you also said that it did have predictive quality to it. So
it was a reflection on the endemic and intentional systematic racism in that region during that time that has persisted to this day in some ways. And it's sad and also fascinating at the same time that you can see that so clearly in a data set that exposes some serious issues with society.
Yeah, I guess that's what I'm kind of aiming at, is because it actually has predictive quality, like what does that actually mean, right?
Mm-hmm.
And yeah, I mean, if you're using it for an example in whatever you're working on, then yeah, go use a data set that isn't problematic. But I also find it interesting that, yeah, going and looking at data sets that start a conversation is also, I think, part of an ethical piece that we need to have, right? It's, okay, well, if we know this and we can predict this, right, based on race or whatever, it's like, okay, well, if we can actually predict that, then how do we help these people if there's something there that is a problem, whether it's societal or cultural or something else, I mean, that we just don't understand at the time. I mean, whatever, right? I think there's real value there. But yeah, if you're using that data set for your examples, yeah, you probably have to pick something else.
Yeah, I think that's a fascinating data point in itself. Like, what does that tell us about the society, like at that point in time, and how it's changed anyway, and how it is now also. But yeah, what you said. It's how the fact that that's even a thing. It tells us a lot. It's very interesting. Yeah.
I'm going to throw out some picks really quickly. So I've gotten a lot of clarity lately on where I'm headed with stuff. I had kind of an idea before, but it's solidifying very quickly for me where I want to end up with my career. Of course, I've got some other stuff going on kind of on the side related to my career as well, just with my current work situation. So that's kind of been a distraction on a lot of this stuff. But one thing that I've been doing a whole bunch lately is helping people out. Usually it's in one of three areas. They either want to advance in their career with their employment situations. They either want a better job or they want to move up wherever they're at or whatever, get better at leadership, that kind of stuff, make a difference where they're at. Or they want to start a podcast or some other media channel, or they're going freelance and they're trying to figure out how to make that work. And I've got experience in all of those and I've been coaching people on all that stuff. So if you are interested in any of those, go to topenddevs.com/coaching. Now, I realize this is probably going to go out sometime next week as we record this, and the website will go up about the same time. So if it's not up, just check back the next day and it should be there. I'm really trying to get it up by Monday, so it's not an issue, but crap always comes up. So, but yeah, and usually what I do is I do a coaching session for free. We'll see if it's a good fit. And then if you see the value in it and I feel like I can help you, then we'll figure out how to make it a paid arrangement. Otherwise, you get a free gift of an hour of my time, and I'm happy to help people. I'm happy to give that up to help people out, because I feel like it's not just about the money. It's about actually helping people out. And so if I give you advice that's going to move you ahead and you're like, hey, this is plenty to chew on for 3 months, I'm good with it, right? The other things I'm going to pick a book, and this is more on the career end of things. It's called The 360 Degree Leader by John C. Maxwell. And it basically talks about managing when you're not the boss, or if you're kind of lower middle management. It also talks about managing up, managing laterally, and managing down. And so that's kind of the 360 degrees. But he makes the point pretty early in the book, and I really love it, is that no matter where you're at, you have leadership options and leadership opportunities, and you can make a difference wherever you're at, right? So don't give up that just because you're not the team lead or not the manager or not the project manager or whatever, right? Find those opportunities to stand up and be an example, stand up and make a difference, go mentor some people, express your opinion if you feel like things aren't going the way that they ought to. I did that yesterday and I might pay for it today, but there are real opportunities for you to do that. And I honestly think that people have a more fulfilling career because of it. So I'm going to pick the book. He explains how to do it all, probably with a little more tact than I tend to do it with. But anyway, it's a terrific book. And he's got a ton of other leadership books that you really ought to be reading if you want to move up in that kind of style in your career. So that was long-winded. I apologize, but terrific book. And then I just finished another book on Audible, and I'll have to look it up, but it's called The Laws of Wealth, Psychology and the Secret to Investing Successfully. And it was a terrific book. And he kind of walks through like market trends and how people decide what to invest in and how they're usually wrong, and how the market is counterintuitive, and what strategies tend to work for people to invest so that they can retire or save up for whatever, or things like that. So if you have like a 401k or things like that, he'll kind of walk you through kind of how you want to diversify and what strategies you want to use for when to buy or sell or things like that. I'll give away one of the big secrets, and it's mostly just buy and hold. But he talks through some of the other ones. A lot of it, if you've read like Money Master the Game by Tony Robbins, some of this is similar and some of this is a little bit more in depth. So yeah, anyway, I'm going to pick those two books because I thought they were really, really helpful in that way. So yeah, those are my pick. And yeah, let's just go ahead and wrap it up here. Thank you both for being here. Until next time, folks, Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.